Hi, my name is C-Dubs, and I just graduated from high school. I took AP BC Calculus, and today we are going to be talking about properties of integrals. And just so you know, if you wanted any practice on like normal integrals and not going over the properties, we have different videos on that. And if you want to just review, you can do this worksheet and then look over it afterwards and look at my answers if you'd like, or you can do it with me. And this is going to be me going over these specific properties. It is a worksheet, but I'm going to be talking about the different properties as we go through the problems, so I'm not really going to talk about them all in general at once and then do them. I'm going to bring them up as they come up in the problems. And then right before we start, I'm just going to note that this is properties of integrals. So this is before you take integrals. So there are no antiderivatives on this worksheet. We are not taking antiderivatives. We are doing the properties of integrals and solving these problems based on the concept that integrals are areas, which they are. So that's what this video is going to be about. So no antiderivatives, just the actual properties of integrals. Okay, so before we start, but I'll use question 1 as an example. I'm just going to give some terms really quickly. So first we have the function inside of the integral. This is called the integrand. It's spelled G-R-A-N-D, and I'm just spelling it because that helped me like understand what the word is. It's like dividend, if that helps you at all, but it's called the integrand. So that is the function inside the integral. And then a little bit more important terms are the limits. So every integral has limits. That's these right here. So the 9 is the lower limit, the 25 is the upper limit, and the number at the bottom is always the lower limit. So just keep that in mind, as I will probably use those terms going forward. All right, so this first problem, we should get started. Let me move this little camera thingy, okay. So this first problem, we're going to be using the negate flip rule. So this is like the basic layout of an integral. We have our lower limit, our upper limit, and our integrand, which is the function inside the integral. And so basically here, anytime we have a function, but we want these two limits to flip, then we use the negate flip rule. So basically, you will just flip the numbers and make the integral the opposite sign. So like in this integral, you can see that we want the 25 to be on the bottom and the 9 to be on top. But we aren't given that. The form we're given is the 9 on the bottom and the 25 on top. So since we want to switch the limits, we're going to use the negate and flip rule. So we make it negative and we flip them. Yes, indeed. Okay, so since it's asking what this is, we're going to start with that and then go from there, because what we want is a number. So we're trying to end up with a number. So we'll start with what is this? And we'll use our given to find that number. So now I'm just writing what we're starting out with. And then here is where we use the negate and flip rule. So we negated by multiplying times a negative, and since it was already negative, the negative went away. And then we flip the 25 and the 9. This should be a 9, not a theta. Sorry about that. And then here, I basically just plugged in what we were given. Since we were given this whole integral equals 196 over 3, we basically put that in here, and then we multiply by 2, and then we get 392 over 3. So that is the answer. All right, nice. So we're going to move on to the next one. Okay, that's a 0. I put a smiley face just for fun. But basically oh, sorry, it's a little blurry there. Okay, but it's a 0. I put a smiley face. But basically what you can see right here is that these limits, the lower limit and the upper limit, are the same number. They're both 4. So when these limits are the same number, anytime they are the same number, the answer is 0, because there's no area. So if you imagine how integrals are areas, the limits are the x values. So basically, like for 9 to 25, it would be like you have a graph, and I know there's no graph here, and it's kind of hard to visualize. But say the 9 is here, and then you draw your line to 25, like going along the function. So you have that, and then you take all of that underneath it, and you find the area, and that's what we're doing with the integrals here. But when you have two limits that are the same, then you don't have anything to take the area of, because you're not really drawing any kind of function. You're just putting a dot, and then there's no area to take. So anytime these limits are the same, the answer is 0. So nice, that was an easier one, kind of. At least you didn't have to write as much. All right, so now this one. We have a lot of different integrals to look at here, and that is me writing the rule that we'll use for this problem, the property. So the property here kind of has to do with midpoints, but I'll just kind of briefly go over it. So here we have an integral with, a function, and notice here that the function is the same in each integral. So the integrand is the same in all of them, and that is important because they do have to be the same. So here we have limits a and b. We have different limits, b and c, but the same integrand. So here, they both have a b in it, and that you need in this problem. So you'll have different limits, but they have one limit that is the same. And since they have one that is the same, you can combine them to create this new one. So you can kind of think of it as them like canceling, but the A becomes the bottom, the C becomes the top. And the reason that this works, briefly cover why this is a thing, is basically the B is the midpoint. So A to C is like one long function, continuous. And so you're taking the area from A to B, and then you're taking the area from B to C. And so the area from A to B plus the area from B to C is going to be the whole area from A to C. And we'll probably talk about this later, but to have the general concept. So here we're given 3 different integrals, and this question is asking us to simplify it into one integral. So we're going to do that using this property right here. So I'm being really slow, but I'm starting out by simplifying these two together using this property. My hand's kind of hairy. Interesting. Wow, and now I'm blocking it. But here we had the -3 on the bottom and the 8 on top. And that is from me simplifying the first two. So the first integral that was over here that my hand is covering is a -3 as the lower limit and a 4 as the upper limit. Oh, now I'm showing it. Nice, okay. And then 4 is the lower limit and 8 as the upper limit. So using the property here, we're basically simplifying it. So we're taking the 4's away and we're creating one integral with just the -3 as the lower limit and the 8 as the upper limit. And then the next thing I did was just copy down the other integral that we had. This was the other integral. So I simplified this, I copied this down, and then because we want to make it one integral, we see that, oh, both integrals have a -3, but they're not in the right spot. They have to be a diagonal from each other. So the way that we fix that is by doing the negate and flip form that we learned in the first problem. So basically, we're going to do that with this one. Here, it doesn't really matter which one you do it with, but generally we like to have the bigger number on top. So that's why we're going to flip this one. So we're negating by multiplying by negative, so that makes this positive, and then flipping the numbers so the -3 goes on top, the 2 on the bottom, and then since they're diagonal, you can then kind of like quote unquote cancel them, and the 8 is on top, the 2 is on bottom, and we have one final integral, which is what we want. So yay. All right, number 4. Number 4 is a newer property. Okay, there we go. Now I'm writing it. I take some long gaps in these videos, man. Okay, so I wrote an F, but I really wanted to write something else, so I'm turning my F into a bracket. we'll just pretend that that looks right. So that's c times a function f plus d times a function g. So basically this property, if I can finish writing it. So right here we have, oh, I'm blocking it. Oh, I moved it. I remembered this time. Normally I don't remember these videos. Okay, so we have this whole big integral, right? This is one function, this is a different function. So something that we can do when we have a very big integral with several different functions is we can separate it. So as long as they're not like connected, as in like multiplying or dividing by each other, since these two are being added together, and this would also work if they were being subtracted, you can separate them. So we're separating the f function and the g function here. And then another thing that you can do after you've separated them is you can take out a constant. And this is very helpful for making the whole process easier, so you can take the area or find the area easier. So if we were to do it in 2 steps, we would have the integral of c times f of x plus the integral of d times g of x, and then we would take out the constant, so we have c in front and then we have d in front. And notice that if you didn't separate them, you would not be able to take out the constant because c and d are not the same, so you can't take them out. But when you separate them, you can take them out. So separating, good. Taking out the constant, good. All of that will make finding the area a lot easier because you will have simpler integrals. Okay. So here's our given, and then we want to find this. So first here, oh, I don't know, what am I writing there? What? Ah, okay. So this right here, first, we have a number. So when we have a number, this kind of a separate property, this is basically the property. So here, this is kind of like an understood 1, but notice that there's no variable or function. So there's no x, there's no like f of x, anything like that. It's just basically a blank integral, but you could also pretend that there's a number here. And anytime there's no variable or function, then you can just follow the form b minus a. So you use the top limit, the upper limit, and you subtract the lower limit. And here, since we have a number, we would multiply by the number. So it would be like 1 times b minus a, because there's like kind of an imaginary 1 right here. So it would be 1 times b minus a, but since we have a 7 here, we would do a 7 here, and then it would be 7 times b minus a. So in this case, it'll be 7 times 3 minus -1, so 3 plus 1, which we will see in a second once I get to writing it. All right, we're writing it, yeah. So first, I'm just rewriting the function so that it's easier. Rewriting the function that we're going to start with, which is not the given. We always, not always, but we like plugging in the given or using the given after we've done some things. So this is me writing what we're trying to find. So what I did here is I used the separate. So since right here, they're not being multiplied, they're not being divided, they're being subtracted. So since this is a subtract, we can separate the 7 and the 3f. And the f is a function, by the way. It's not like a variable, it's a function. So this is me separating it. And basically when I separated it, I took out the constant 7, since it's a constant, and this was the imaginary 1 that we were talking about. So it's not really imaginary, but it's like kind of in parentheses. Like it's there, but you can't, anyway. So we took out the 7, we put it in front to make it clear that it's a constant. And then here we took out the 3, which is also a constant. All right, cool. Moving on. So now the 7 times 4. So if you remember what I said earlier, we would do 7 times b minus a. Here we're doing the 7 times 3 minus a -1, and 3 minus a -1 is 3 plus 1, which is 4. So here we have 7 times 4. And then we have minus 3 times 1, because right here, we basically plugged in the given that this integral, if you don't look at the 3, if you ignore the 3, we have our given right here, and we know that that equals 1, so we're doing 3 times 1. And 7 times 4 is 28. 28 minus 3 is 25. So yay. All right. Number 5. So number 5, we're going to use separation again. And I think it's pretty clear if you look at the problem. Oh, it's slanted. It's fine. Okay, so if you look at the problem here, I think it's kind of easy to see right when you look at the problem that you're going to be separating because you have the two different functions and they're being subtracted. So since, again, we're going to start with what we're finding the area of this whole integral, so we're going to start with that. And again, we're starting off with separating them and taking out the constant. So we separated the 2 times function f minus the 5 times function g. So we separated, we took out the 2, we took out the 5. And also remember, I didn't say this in the last one, but remember that this limit is the same for both of them. It doesn't change. So then we see that we have 6 and 0. We have the 0 and the 6. And we need to make them diagonal so that we can add them together like we used earlier. So here we're doing the negate and flip so that the 6's are diagonal from each other. So the negate, we're making this multiplying by a negative, which makes it positive, and then we're flipping the 0 and the 6. And then here we're going to use our givens. And the reason that we flipped it, I don't know what I said before, but the reason that we flipped it is to match this given so that we can plug it in. So disregard what I said before because we're using it for the given. And this, we see here, it already matches the given, which is a good sign. So we're using our given 8 here, we're plugging it into this, so 2 times 8, that's right here. And then since we negated and flipped, this now matches our given, and so we do 5 times 6, and then we get 46. So there we go. All right, number 6. So first what we're going to do here on this problem is simplify because we always want to isolate the integral if we can. In the other problems, we were always given integrals like this, where there's no constant in front of it. It's just the integral equals a number. But right here, there's a constant in front of that, and if possible, we want to try to get rid of it just because it makes solving the problem more simple. So what I'm doing right here, I cross them out so that I remember in my head that those are not the numbers we're using anymore. But you can also write divide. So we're just dividing by 2 on this side, and then we're dividing by 2 on this side, so we get 5. So no more constant in front, just the integral, and now we have a number. So integral equals a number is the format that you want with your givens, if you can. All right, now we're going to do the problem. Again, we have a format where when you just look at it, you can kind of tell that we're going to be separating it because it's 2 different functions and there's an addition in between them. So we're going to write that down, we're going to separate it, and we're going to take out the constants. Once you start doing these problems a lot, you'll get into a kind of rhythm where you see that format and then you immediately separate and take out the constants. So that's what we did right here. Sorry, it's a little blurry. But we separated the 3 times the function f, and then we took out the constant 3. We separated the 2 times function g, and we took out the 2. And then here we're trying, again, we always want to try to match the given. So since our given has the upper limit 1, lower limit 3, but here we have the upper limit 3 and the lower limit 1, we know that we need to flip those so they will match the given. So we're going to negate and flip. We multiply times a negative, and we flip them. So now this right here matches this given. So now we'll be able to plug it in. Now here are 3 as the upper limit, 1 as the lower limit. That matches our given, so we're good, and we can just plug in the negative 4. So that's what we're doing here. Our 5, we plug in, so negative 3 times 5, negative 15, plus 2 times negative 4 that we're plugging in here. And we get negative 23. There we go. All right, so moving on to number 7. So number 7 is basically the same rule earlier where we're, again, using that kind of like diagonal thing where we have two different integrals, like these two, with the same number, where we can kind of simplify it into one integral. But this way, this time I'm just writing out kind of a concept that makes it maybe a little easier to understand. We call it small, middle, big. And basically you put the small number on the bottom, you put the middle number on the top, and then you put the middle number on the bottom here, and the big number on top, and then you'll get the small number here, the big number here. And sometimes that's just easier to visualize. Instead of having like A and B, you have small, middle, big, and it's kind of like something easier to remember when you're doing problems. So again, we're starting out with the integral that we're finding. So with our 9 and -1 limits, and then we're going to try to use our small, middle, big. So we're starting with this function because we see that we want a -1 on bottom. So since we want a -1 on bottom, we're going to put that in. And then we see, oh, look, this right here. Oh, these match. Oh, small, middle, big. That works out great. So we have our -1, our 8, and our 8 here, and our 9, so they're diagonal. And then we get the small one and the big one, and they match here, which is awesome. And then we're just going to plug in these numbers that we are given. So that's 3 plus 5, and then we get 8. So there we are. Okay. Number 8. So again, we're starting with our find. Oh, you know what I just realized? That, I think... Actually, you know what? No, we're good. Okay, in this problem, we're not starting with our find. We could start with our find. You can always start with your find, but you don't always have to start with your find. You can start out with whatever is easiest in the problem. So here we see, when we're looking at the problem, we see that we have these 2's that match, and we have, oh, there are also 0's, and then here are the 5's. So since these two are already diagonal from each other, if you want, you can start with these two. Instead of starting with the find, you can have this one because you know that these two match. So you know that you want to add them together. So if you see two where they're already in the right format, you can start with those. So that's what we're doing here. We know that these two, you add them together, we'll have a 5 and a 0. Oh, and there's our 5 and our 0. And then you can solve it more kind of algebraically. So basically, we want this, and we'll find it by using these two, which we're given. So it doesn't always have to be this is equal to this plus this. It can be something else. This is a little confusing, but anyway, you can do it whatever way you find simplest. So if you find the simplest way being not starting with this, then by all means do it. So basically we have this setup that I was talking about before, and now we're just going to plug in the givens. So here's our given here, that equals -1, this equals 6. So this is what I'm saying where it's more algebraically, because now we're going to subtract the 6 so that we can now solve for this integral specifically. So, yep. Subtracting the 6, -1 minus 6 is -7. So that is, that's what it's equal to. Sorry, I'm moving kind of slow. Or maybe this is a good pace. I don't know. Whatever's best for all of you. But there we go. -7. That's our answer. All right, number 9. So let's just look at this. Oh, my hand keeps getting in the way. So we have a 2 and a -6, and then we have a 6 and a 2, and a -6 and a 6. So we want to find this. But let's just look around and see if any of the diagonals match each other. So we see those don't really match. Oh, but these do. So we see there's a 6 here, there's a 6 here. They're already diagonal. So maybe we want to go with that. So maybe we want to say this is equal to this plus this. Or actually, I guess it'd be the other way around. It would be this plus this, but that is what we will see. So again, if you want to identify the ones that are already in the correct format and use those, that is a very good method to go with. And again, with the small, middle, middle, big. So if you always, if you can, you want to start with the smallest one in the middle here, which is why I was saying earlier, actually, it's going to be this plus this. Remember, it fits that format, small, middle, middle, big. So what we did here, we set it up, and then we equated it to this one right here, since that is, what is that what it's equal to? Well, now I'm a little, oh, okay, sorry, I got lost for a second. So we're not equating it to this, but we will plug that in a second. So basically, sorry, I confused myself. Here, we like this format, so I just rewrote it here. But then for this one, why did I flip it though? So I could plug it in. All right, sorry, okay. I apologize for not getting that one right, but I'll explain it clearly now. Okay, so this one, this is already in the format of our given. So right here, this is this. So right here, we can plug 3 right in because it's in the right format. This one is not in the right format because we want the 2 on top as the upper limit and the 6 as the lower limit so that we can plug in 5. That is what we want. So when we plug in, well, we're not plugging in yet. We're negating and flipping. So we want this in this format, so we have to multiply by a negative and then flip the signs, which is what we do there. And the reason I was confused is because I didn't see this integral, and I was like, where is that integral? So I'm sorry for not writing it, because that was a little confusing. So this whole thing right here, oh no, I moved my thingy. I was not supposed to do that. I was trying to draw a box, but you can see the box, it's okay. So this plus this, if you get rid of the diagonals, is the -6 on bottom as the lower limit and 6 on top as the upper limit. So this here is equal to this whole thing. So to get rid of the confusion. I confused myself on that one, I'm sorry. But anyway, this is our given. This we negate and flip to make our given. And then we plug in our givens. 3 minus 5. -2. Bam. That is this. Should have been an easier one. Sorry about that. But we got through it. Everybody makes mistakes. Okay. So on this one, we see here, we see that format, we see a subtraction, so we think we're probably going to be separating our integrals again. So we're back to separating. But look at all of these different numbers. When you see 3 different numbers, especially 3, that's pretty indicative that you're going to be doing the small, middle, middle, big. So we're going to be separating and doing small, middle, middle, big. So doing a lot in this problem. So first, we are going to start out simplifying this one, because again, we always want to make it an integral equals a number, but since there's a constant in front, we want to try to get rid of that. So we're going to cancel out the 2. We're dividing by 2 here and dividing by 2 here. So the integral equals 4. And then we are going to start out by solving for this function. We want to get the integral with this function, so we want to get 4 as the upper limit, 1 as the lower limit, and we're doing that by using our givens. So we're starting out with this given, we're saying this is equal to this given, and this. Yeah. The 1s there are the diagonals, so they cancel out. The -2 is the lower limit, the 4 is the upper limit. So given, and then this right here is this little section of the integral. The 4 is the upper limit, the 1 is the lower limit right here. So the reason that we're doing this first is so that we can find this and plug it in later. So we're going to plug in our givens. So here's our first given. We have 3 for this, and then our second given, which is now 4 because we originally simplified. So we're going to put 4 here. And then we have our integral, and then using algebra, we're just going to solve for that integral. So 3 minus 4 equals -1. And then we are going to now separate. So first we did small, middle, middle, big. We did that one. And just to point it out, this is small, middle, middle, big. Okay, anyway. I know you know it, but I'm pointing it out anyway. And now that we've solved for our integral here, now we're going to separate. It's a longer problem, several steps. So we're going to separate first our 6. And our 6 is one of those special ones. We're going to do that number times b minus a. That's me just rewriting it. But when we see a number, we're going to do the number times 4 minus 1. 6 times 4 minus 1. But here's me just rewriting it. So I took out the constant, our imaginary 1 that we love. And then here, again, separating that, taking out the constant, making it easier. So that's 6 times 4 minus 1, which is 3. And then we have 3 times, oh, it went away so fast, oh no. Okay, sorry. 3 times what we found right here. Remember to go back and use what you found earlier in the problem. So we found the -1, so we're plugging that in right there. So 3 times -1. So 18 plus 4 is 20. Is it? Plus 3. Oh wow, that was rough. I'm sorry. 18 plus 3 is 21. Okay. Today's a rough day for in my head. Okay. I haven't done math in a while. But it's okay. We're working on it together. Okay, number 11. Woo! So I started this problem out kind of rough because I tried to force small, middle, middle, big. And then it didn't end up working because keep in mind that you don't always have to do small, middle, middle, big. It doesn't always have to be the smallest number and then the middle number and then the biggest number. It can be middle, small, small, big, or big, small, small, middle. As long as the diagonals match, it works. But small, middle, middle, big is like a good thing to keep in mind just because it helps you remember. So see here I did the format, small, middle, middle, big. But then it just, I was like, well, if I do -3 and 5, well, -3 to 8, but -3 to 8 wasn't what I wanted. Like, if you look at it here, what I was doing is I saw the -3 and the 1, and I saw the 1, where's the 1 and the, wait, I don't even know why I put a 1 and a 5. I really don't know what happened here. But I was like, oh, I'll do small, middle, little, small, middle, middle, big. And so I started like writing things, and then there wasn't even a given for that, and it also was not what we wanted to find. So like there's not even a given for this one. There's not a given for this one or this one. And we don't want to find either of them either. This is what we want to find. So it was just a whole mess. So I apologize for that. That was rough. But it's okay, because we will figure it out. Basically what you want to do instead of trying to like force it in your mind is you want to look at what you're given and then like put them together instead of like throwing random integrals on the page. So we're looking at what we want to find. So let's just start with that. So we start with what we want to find, and we're not going to write the whole thing out. We just want to write it more basic so that we can then plug things in. So we're starting with what we want to find. The 8 is the upper limit, 5 is the lower limit. And then we want to try to do small, middle, middle, big. And this problem is a little harder because there are so many givens. There aren't just 3 numbers. Well, yes, there are 4 numbers. Okay, good, I can count. So there are 4 numbers, which is harder to do small, middle, middle, big, because there isn't just a small, a middle, and a big. There's another one. So you're going to have to do another addition or subtraction. Well, addition is the property, so it would be addition. So we started with our find, which is a good place to start. And then we basically started with 5 as the bottom. That's another good way to go, is starting with the number that's on the bottom because you know that you'll need it. So basically what we did is we used this, and we then flip it later to match our given. So we're going to flip it later. Keep that in mind. But we're relating it to this given right here. And then here we have our other given. So that one we're not going to have to change at all because it's right. And the numbers are in the right place. But this one, they're flipped. So we're going to have to fix that one. And then since these diagonals match, we've got our lower one and our upper one. So we have 5 and 1. And then when we have 5, 1, 1, 8, the ones, they're the diagonals, they go away, and then we have 8 and 5. So that's what we want. And this can be a little hard, but again, it's good to just start with the number that's on bottom and then work your way. So since we started with the 5, we took the one that had the 5, we put the 5 on the bottom where we want it, and then we just flipped it so that the 5 was on bottom. And then we have the -3 here, so then we look, we see where the -3 is. Oh, here's the -3. We put the -3 here. Oh, we have a 1, okay. Oh, 1 and 8, okay. Well, we might have to flip that to match our needs, but that's okay, because we'll work with it later. And then we have our 8. So basically, you do what you gotta do in order to get the final numbers and limits that you want there. Took a while, but we got there. So that's our basic setup. And then we're gonna start plugging in the actual integrals and flipping them the way we need to flip them, negating and flipping, so that we can get our next step. So what we did here is I did the negate and flip, so that became negative, and we flipped the numbers so that we could match our given. And then here, since it was already in the right format, we just plugged in our given, that's 2. And then again, I had to negate and flip since this is not in the right format as our given, so we put a negative, we switched the numbers, and that is now ready to be plugged into as well. So then here we plugged in all the numbers. So we have a negative of our given, so -7 goes in here. Our 2 is already there. And then we have, oh, here's our other 2, negative, there we go. And then we get -7. So keep in mind, oh, sorry, it's weird, but what we just found was that this integral, 8 with the limits 5 to 8, that whole integral equals 7. That's what we just found. And what we're gonna do is we're gonna use that when we are doing our separate, which is our next thing. So we did all of this so that we can plug it into here in a second. So right now what I'm doing is now separating. So we're taking this, we're separating the function and the 3 because we see that subtraction. So when we see that subtraction or addition, we think separate. So I separated, oh, well, I just wrote it out first. And then I separated, and again, remember, take out the constant. So I separated this as an integral, and then I took out the 2. And then here, instead of writing it out like I did in, say, this one right here, if you look right here, I wrote out the integral again, which you can definitely do that if it works better for you. But instead of writing out the whole integral, I skipped a step, and I just went into doing the multiplication. So like here, it would have been 6 times, and then 4 minus 1, and then 4 minus 1 is 3. But here, instead of writing this and then writing this, I just did it in 1. That was my dad yelling in the background, I'm sorry. And here, I just wrote 3 times 8 minus 5. 3 times 8 minus 5. So I skipped a step. But if you want to do it that way, it's a little faster. And then we're going to plug in the number that we got right here, the number that it took us so long to get. We got our -7. Now we can plug it into this function. So we have 2 times -7, and then minus 3 times 3, which is what I will write right now. There we have it. And we have -23. -23. There you go. All right, so close. Two more problems. I'm so sorry. Okay, 2 more problems. We are so close. Just hang on, hang with me. We're almost there. Okay, so again, always try to simplify if you can. We divided by 2 here, we divided by 2 here. We want that integral equals a number. So that's what we have now. So we simplified. Oh, and look at that. We have subtraction, 2 different functions. You know what that means. Separate, yeah. I hope you said it. If not, that's okay. It's cool. but we're going to separate. But separating is always the second step because we have to make sure that we have things to plug into these when we do separate. So we're going to do small, middle, middle, big, yet again. How's it come back? These last problems, they're harder. Oh, I messed up again. It's okay. It's cool. So here we are. We're writing it. See, remember this? I know my hand's covering it again, and I apologize. But these are the limits for the integral that we're going to separate later. So this is kind of what we want to start with because it's what we have for our separating integral that we're going to do last. So here we are. We're using that bottom number starting there. And then, oh, here's our given. So we're using our given. And then, oh, we're matching that. There's the diagonal. So we have 1, 6. And then here, we're plugging in those givens. So 2 plus 3. And that, there we go. We get our 5. And we already have a given for G. So we don't need to do anything there. So what we were doing was finding the given for H by using our givens. Not finding the given, but finding what H is equal to using our givens. And then we already had our given for G. So we are basically finding numbers that we're going to plug in for those. And now, this is the problem that we had. So I rewrote it here, so it's easier to see. And then I separated them. And this time, they don't have any constants, but if there was like a 2 in front of the H, the 2 would be right here. Because we're going to separate and take out our constants. And then here we are. I plugged in what we got right here because this was already in the right format. But our G was not in the right format. It was not in the format that we got in our given. So we had to negate and flip. So we multiplied by a negative and we flip the numbers. So now it matches our given. And then here we plug in our given. And there we go. That one went a lot smoother than the last one. Practice makes perfect. Still not perfect, but practice. Good, nice. All right, this is the last one. Yeah, woo, last one. All right. Okay, so again, I'm just gonna point it out every single time because it makes it easier when you notice these things right when you see the problem. So here, our find. Look at that, 2 different functions, addition or subtraction. You know we're gonna end up separating. And same goes right here. But, oh look, lots of numbers, at least 3. That means we're going to be small, middle, middle, bigging. So get ready for that. And generally, I'm sure you've noticed here, but generally we're going to start with small, middle, middle, bigging. And we're going to do the same thing on this problem. But this time, oh, well, first we're going to simplify. We've got our, what was this, a 3 and a 9. So we are, even if the constant is inside the integral, we still want to try to get rid of it. Just because, again, it makes the whole process simpler. So we divide it by 3, we divide it by 3, integral equals number. And then, and also remember that the constant right on the inside is the same as it being on the outside. So when I say integral equals a number, if the number is here, then it's like number times integral equals. Okay, anyway, we just want an integral times number. Okay, this one we divided by 1/2, which basically means multiplying by 2, so negative 12. All right, we've simplified. So now we're going to do our small, middle, middle, big. But realize that one of our givens is a big bracketed integral. But that's okay. We're still going to use it. We're going to continue to use it in our small, middle, middle, big. You just, here we go. Actually, are we even small, middle, middle, big? Oh, okay. The first step is not small, middle, middle, bigging, but we will small, middle, middle, big soon. Fear not. Okay, so this is our given. It's one of our givens right here. And we're going to separate, which is what we're used to when we see the addition and the functions. So we separated the f out, we separated the g out, we moved the constant out. And then here are our givens. So we're plugging in our givens. So we know this function equals 3 here. And then we see our 8 and our 1, but they're not in the right place. So we flip them. So we have to negate and flip. So we make it negative and what did I plug in? I'm confused. Oh, we're not there yet. We're not there yet. Sorry. Here's the negate and flip. I thought it was the number itself, but then I just realized I didn't see the actual integral. But anyway, we negated and flipped, and then we plugged in the negative 12 from here. And that equals 51. Now we're going to small, middle, middle, big. So why are we doing this, you may ask? We're doing this so that we can find this big thing, because that's the goal of the problem. We want to find that. And since it's a bracket, and we've already been given a bracket, we can small, middle, middle, big with the brackets, with the big integrals. So we're keeping in mind here, this is a given right there. This, we just found it. We found it so that we could do our small, middle, middle, big. So here, look at that. There she is. Oh, 51. So we're going to plug that in. And then we have our given. That equals 1. We're going to plug that in. And also keep in mind, here's the 1. We started with our small one. And then we have the diagonals, the 3s, and the 8. So we have 1 and the 8 become. There we go. But we're plugging in 51 here. We're plugging in 1 here. I don't know why I'm not writing yet, but that's probably just pondering those properties of integrals. Yeah. Oh, and you can't even really see it. Okay, hold on. Let me move this. Oh, wait, no, you can't. I'm sorry, you can't really see it. I'll just, okay. Well, the thingy's now kind of in the way, but, oh, there we go. We're good. Okay, so we plugged in the 51, we plugged in the 1. Ah, now I can't use my cursor. Okay, it's okay. I'll learn for the next video. So the 3 and the 1 limit the thing we want to find is right there. We use algebra to basically solve. We do 51 minus 1, that equals 50. So then we have this whole thing equals 50. 50 is the answer. And that is the last question. So we're done. Yay. So thank you for watching my video. I hope you enjoyed. I'm sorry for all the mistakes, but we're all learning math, right? Yeah. Anyway, properties of integrals. This is kind of like a basic thing you need to know for integrals, kind of pretty important for calculus, as integrals are a very common topic. While normally you're going to be taking antiderivatives with your integrals, knowing the basics and the properties and the concepts behind the integrals is important, and knowing that you can use these methods for finding your integrals is very important. So it's good that you know all of this. If you want review on the antiderivative version of integrals, then we have videos on that. If you want actual review of properties of integrals, I'm sure there's a video on that. We have lots of different types of videos on this channel, so if you need help on any A, B, or BC topic, then feel free to browse our channel. I'm sure we have it. We have many, many, many topics of girls around my age teaching these topics. It's very useful, especially for AP exams. Anyway, I'm rambling. Sorry. Hope you enjoyed this video. I'm C-Dubs. Subscribe and like if you want. Thank you. Bye-bye.